Welcome to my presentation. I'm Drew Rapenchuk. I'm from Bloomberg. Bloomberg is a company. We're a data services software company. So essentially, the bulk of what we do is we're taking publicly available data and we transform it into a product that other people consume, essentially. Our team specifically, we do web operations. We're the WebOps group, and specifically the web operations for Bloomberg is a very different thing from terminal services, whereas terminal is our core product. This presentation is going to be kind of an implementation story about how we implemented Kubernetes for the web world at Bloomberg so far, and kind of going over some of the pain points that we've had, why we made some of the decisions, and looking forward how we may need to change things in the future. So nothing's necessarily set in stone. So a little bit of a history, again, a little bit of a caveat is we have multiple teams responsible for delivering platform solutions to many places in the company. We're specifically WebOps. We do platform engineering. We do system security. We do deployment methodologies, all for the web world. We have various teams, such as the DTP team. They're also doing another Kubernetes implementation that really focuses on microservices and use case that fits them. And we also have multiple other teams that are doing different platform as a service type solutions across the company as well that are targeted at their use cases. So the reason why we kind of went our own direction is because we have unique needs in comparison to everyone else within the company. So the WebOps team in Bloomberg, we create tools and adopt technologies to improve efficiency for the web teams. We manage software packages, we create methods for deploying new software, and we create the tools that are required for software teams to be able to get their applications out to the consumers. So generally, we're not directly managing, historically, the deployment of the applications themselves. We create the packages for the frameworks. We create the standards for deploying their configurations. But again, these teams like to maintain control over when they're deploying and how they're deploying and why they're deploying, because we have multiple teams underneath us that all have various needs. They all use different programming languages. So again, our team really focuses a lot on setting standards and coming up with best practices and trying to help these development teams reach their goals. So what's the problem with that? Again, kind of how we went into, kind of how I described that we create these methods and we create standards. A lot of time is spent on communicating with the teams. We're trying to describe to them how they should go about doing things. We're not necessarily setting things in stone, but the issue with that is that we spend a lot of time on training them, a lot of time on education. A big part of that problem is when people move around within teams, within our development teams underneath us, that it requires various developers to relearn methodologies specific for their team. There's a lot of effort into changing the standards. When someone spends all that time trying to learn a new process, learn a new method, they don't want to relearn something again. I'd never want to relearn something when I know that the process I'm doing works unless I absolutely have to. So it ends up being a huge burden on the developers themselves, and that really ultimately kind of leads to a poor developer experience. And that's one of our jobs, is to create a developer experience that's going to be good for our developers. We also spend a lot of time on keeping the lights on. We do a lot of effort on maintaining log rotations. We do a lot of effort on helping to troubleshoot issues with old legacy deployment mechanisms, and we spend a lot of time revamping old solutions that probably aren't going to be sustainable in the future. And another problem we run into, and this is kind of a recurring issue with us, is we have very little infrastructure automation. A lot of stuff that we have historically is still very ticket-driven, ticket-based. A lot of it's manual operation. So we can kind of create some tools that can interact with the infrastructure in a somewhat automated way, but again, a lot of the things like firewall rules and stuff like that are still relegated to another team that has to go into a system somewhere and plug something in, or at least we have to wait for approval at some point. So it makes automation of our system really difficult at a lot of times. So what do we want? What's the main overarching theme for, moving forward with our products? We want the developers to have a better experience. We want them to be able to deploy their application how they want to, when they want to, in the method that they want to, in a simple way. The developers want to only focus on their apps and not the infrastructure. Again, traditionally, the application developers also own their servers. They're not really system administrators, they're kind of pseudo-operators, but for the most part, they were responsible for the infrastructure. Again, part of the reason that we need to get away from that is because when something does get messed up, we end up having to help them to repair that issue. We, as a team, want better control of the chaos. So we want to really have a lot more of a standardized method for deploying these infrastructure services. We want to set up the servers, and we want to kind of take more control away from the developers where they don't necessarily need or want that control. A lot of developers don't want to mess with the infrastructure. Why should we force them to mess with the infrastructure? And we also want more efficient use of resources. And this is a big one, because with most companies, there's always a lot of idle time with CPU, a lot of idle time with your servers. If you have virtual machines laying around, most of the time, if you don't have very elastic scaling mechanisms, your servers are sitting there doing nothing for most of the day, and you're not getting economical use out of your resources. So the first step in problem solving is identifying what your problems are and then proposing solutions to your problems. This leads to a discovery phase where you spend a lot of time on research and a lot of time on trial and error. So what specifically do we want? Most of what we want is easy in concept, but perhaps it's not so easy in implementation, especially in our infrastructure setup where there isn't a lot of automation. So we have to create those automation systems, or we have to come up with a mechanism that's going to work around the automation or allow us to take control of automation. So either we'll virtualize stuff or we will, implement a framework that's going to take control of a lot of those functionalities. So we want improved deployment cadence for applications. We want improved availability, improved portability, security, tighter control, simplified scaling, and easier management. All of this is conceptually easy and great, but in implementation, it's not necessarily so easy. And the biggest thing that we're driving for this is support for 12-factor applications. In the Bloomberg web world, we're really trying to push stateless applications. We don't want to necessarily store the data with the application. Perhaps maybe the application talks to some backend somewhere and gets some data from something else, but we don't want to store state with the application. We want it to be lightweight, and that leads to the ability to scale the application a lot faster in and out, get better resource utilization, and that allows us to start to automate these processes a lot more efficiently as well. So what technology can we use and what can it get us? So we have to spend a lot of time on thinking about what specific technologies we want to use. So after we got a concept of what the solution is that we want, we kind of have to play around with the specific technologies. Do we want to use Linux containers? What are we going to do for logging? For a CICD workflow, what are we going to do that's going to work for the developers, but also allow us to retain the control that we need? What security mechanisms are we going to implement, because we also want to improve our security posture? What are we doing for monitoring? What are we doing for scheduling? These are all the same questions for the entire platform moving forward. We want to take control of all of this stuff, and we want to come up with a very solid mechanism that's going to be more maintainable for us moving forward, and is going to be flexible enough that we don't have to completely redo the entire system at some point in the near future. So it's going to be worth our effort. So we kind of have to sit down and we evaluate multiple technologies for each one of these things. So are we going to look at Mesos? Are we going to look at Swarm, Nomad, Kubernetes? So back when we started looking at these technologies, it was about a year ago now when we started doing POCs. And we kind of spent a lot of time throwing back and forth what's going to work best for us. And of course, it doesn't matter what you really choose in the concept and planning and design phase. When you go to implement it, you're most likely inevitably going to run into some sort of issue that's going to lead to a change in your plans. So what are we trying to prevent? We don't want vendor lock-in or tool lock-in. So we're trying to stay away from proprietary tools. We're trying to stay away from something that's going to make it so we can deploy this method somewhere else. If we want to deploy to multiple clouds, we can't use cloud provider specific functionality because that cloud provider specific functionality isn't going to exist on our internal infrastructure, for example. So we need to retain that flexibility that if we want to expand out to AWS or Google Cloud Platform or something like that, we can't use something that's super specific to them or super specific internally. We want to prevent perpetuating of bad habits. So again, taking some of the control of the developers away so they don't have to continuously educate themselves on best practices for some of the stuff that we can control, and they can spend more time on the actual coding of the application where we can solidly maintain the best practices in development time. So we want to avoid general inflexibility. Again, we don't want specific functionality that's not going to be flexible, and we may end up having to completely replace a part of our whole framework moving forward. And we want to avoid setting ourselves up for failure. Again, this is kind of common sense, but when you see the shiny surface of a new technology, sometimes you don't really understand what the possible negative impact could be underneath it sometime down in the future. So it requires a lot of testing and testing and testing and testing. So what choices did we make and why? So for containers, we went with Docker. One of the reasons is because it's been around for a while. It's already understood by people. There's lots of tools and support around the community. It's stable and secure if you use the right provider, and it can be replaced. So there's a potential to use something like Rocket or other container runtimes where you can replace it, essentially drop in replacement for the deployment methods, and you'll still be able to retain your development processes on the inside so the developers never have to change anything on their side as well. So we can take the runtime, we can get rid of it if it ends up being too much of a burden for us to use, or if we see that the community as a whole is shifting a different direction. Another added benefit is because when we go up to management and we say we want to start doing containerized applications, a lot of times management doesn't like the sound of that. It's a new technology, it's kind of scary. So you do have to kind of, meet at a happy middle ground and say like, well, we're going to use Docker. It's something that it has the established name. It's an understood technology that other companies are using in production perhaps. And that really is a big leveraging factor with getting management and security on board is they want that fuzzy, warm feeling that other people are still doing this. So we don't necessarily want to jump to the very, very cutting edge and use Rocket because that's kind of setting ourselves up for failure in the future. Someone may not like that in the management chain just because it really isn't proven. So for logging, we went with FluentD. Why FluentD? It's super simple, it's super flexible, and it doesn't tie us to any sort of a specific backend. So we can use various plugins in order to pump it to Splunk. We can pump it to Logstash. We can pump it to S3. So we can dump the logs wherever we want to if we need to in the future. So if our logging backend that we have provided or we created changes at some point, we don't have to completely remove our logging mechanism and redo it. We're not locking ourselves into a specific process. So it's a simple configuration change moving forward. For CICD, we're using Jenkins. A lot of people don't like Jenkins. Personally, I think it's a little clunky, but One of the advantages is it's been around for so long, developers are familiar with it, management mostly understands it, it's relatively simple to use, and allows for strict security controls and job creation and job management and access and authorization schemes. For security, OpenSCAP. So we want to do security scanning. We want to make sure that these applications that we're putting into production don't have vulnerabilities in them. They don't have innate CVEs at them on the bottom level that are going to cause us to potentially be more chaotic in the deployment where we're going to have to remediate problems in the future. We are using TLS Trust because we need security of the APIs. We don't want everyone accessing our APIs and just doing whatever. And part of the problem with potentially tokens is someone could theoretically generate a token, depending on how complex it is, and still access your APIs. So you need HTTPS access, you need that encryption, and you need that at least first layer of security there. And we want centralized access. We don't want to have to distribute this authorization mechanism to everyone. We don't want to give TLS certificates to everyone. We don't want to give tokens to everyone. We want to maintain all of the access to our registries, to the APIs, to everything. Because when you start distributing secrets and keys and stuff like that, you're getting into key management. That's another layer of management that you have to deal with. So you're creating more work, you're creating more KTLO, you're going to have to redo the system at some point eventually. So everything that you create, you're going to have to redo at some point. It's inevitable, that's tech debt, it's how it happens. So a lot of our deployment mechanism is Jenkins based. It's shell scripts for the most part right now. It's easy to read, it's very simple, and we're doing relatively basic stuff, but we're implementing it in a way that's really feature-rich as far as the deployment mechanism, but it's secure and it's also easy for the developers to use. So for metrics, kind of a custom dashboard. We're using Heapster and Prometheus. These are already kind of understood standards for container metrics in the world for the most part. We have a little bit of a custom dashboard so we can display the metrics that are going to be useful to the application teams, but we want to abstract away a lot of the fluff that's not useful for them. They don't care about necessarily like how much memory DNS is using on their cluster because why would they care? They want to know what their application is doing. We theoretically own the infrastructure, they just own the applications. So we care about DNS, we care about everything, they don't. Why show it to them? So for orchestration, of course, we went with Kubernetes. We wouldn't be here if we didn't. The reason why we went with that is because the biggest reason is the community and the development pace. Every few weeks, there's a new minor release that's being cut that has more features. If you need help with something, you can always reach out to the Slack channels or anything like that, or the GitHub issues, and people are always willing to help you. You don't necessarily need a support contract with someone to help maintain this or try to figure out vague issues with some weird mistype in the code somewhere. There's going to be someone somewhere in one of the special interest groups or the standard user groups or something that's going to know this problem exists and why it exists. And it's going to get fixed pretty fast. So it's a very simple to use tool once you get it implemented. Configuration and implementation itself, maybe not so much, and we had issues with that. But once you get it in place and you get it working, it's actually a lot of it's kind of common sense from a top level perspective. It's simple to use, and we actually find it very supportable moving forward. So it's also got self-cleaning and self-healing mechanisms as well. So we no longer have to come up with any sort of logic loop or something like that to fix an application when an application dies. If an application dies, you point a health check at it, Kubernetes is going to see that it's dead, and it's going to try to recreate it and try to heal it itself. So there's a lot of stuff that's built into Kubernetes natively that's going to try to fix our problems for us. So we're kind of killing two birds with one stone there. So, the $6 million plan. We have the technology. We want to make it better than it was. Better, stronger, faster. We hope. So as with every implementation story, a lot of people will tell you that, oh, it went great. You know, and when you go up to talk to any of these folks that are giving these stories here, a recurring theme is everything is great now, but this, and this. You're always going to run into roadblocks with new technology. And that's okay, that's understandable. You shouldn't be discouraged by running into issues. You shouldn't be discouraged by having to look at documentation or maybe even having to take a peek at the code or asking other people in the community for help. That's normal. But there's also stuff that's not directly tied to the technology itself that you have to work around when you're in a large enterprise company like ours. You may have a change in the project scope. You may have to abstract terminology like we are. We don't want our developers to have to learn Kubernetes. We learn Kubernetes, we give them a deployment mechanism. So we try to retain a lot of the standards and the terminology that they already understand and know. The only difference is, okay, they'll have to kind of learn what containers are and how containers work, but for the most part, all of the specific Kubernetes things, such as pods and stuff like that, they don't have to learn that stuff. We're going to abstract all of that away from them. We also have to satisfy the security team. So again, a big part of that is unknowns. Before we came along and started deploying applications on containers, it was very much so untested by most people in the company to deploy containerized applications. So this whole thing was not even just implementing a new orchestration framework that is Kubernetes, but we're also adopting a new technology, which is Linux containers. So it's a lot of big changes to a lot of things for security teams and management that they don't necessarily understand. So you have to kind of hold their hands a little bit. Not saying they're stupid, but they don't understand a lot of this stuff. Us as the technical people, we have to help them along to understand that it's not so bad if we do this. It's not terrible if we take this measure to mitigate the risks. So again, we had to spend a lot of time working with the teams that are going to be deploying applications on this. So we had a proof of concept application where we planned for release, and we had to work hand in hand with them so they're comfortable with the deployment mechanism and we're not making it too chaotic for them to adopt this workflow. If it's too hard for them to adopt the workflow, they're not going to want to use it. And like I said, a lot of effort is changing people's minds. So how did we make it look good in the end? That's the key point with a lot of these presentations is how did you make it happen? So there's a little bit of magic going on, but it took a lot of patience. It wasn't exactly, oh, we'll start playing with Kubernetes this week and we're deploying applications to production next week. No, that's definitely not what happened. We had original plans to deploy to public cloud, and then we kind of changed in scope, so we're not deploying to public cloud right now. But we need to maintain that ability to possibly deploy to public cloud in the future. So we had to shift infrastructure. We had to change a lot of stuff at a high level, but we also spent a lot of time on education and a lot of time on tiny little small are and redo what you want it to be. Necessarily something's going to be head out. We also wanted to stay away from Docker Hub because we don't know necessarily what people are building on that. We don't necessarily trust the images that are there. Not saying that everyone's untrustworthy, but we have a duty to our company to make sure that our applications are built a very specific way. So we're security scanning our containers. We're creating base containers for the application teams to use. And we're also making sure to the security teams and to the application teams that these are meeting a standard for deployment. And again, lots of testing. So what do the clusters look like? Nothing amazing, right? So we have application load balancers, essentially. We have an internal load balancer for managing the APIs. We have workers, we have nodes, and we deploy to multiple tiers, dev, staging, and prod. It's a very understandable setup. This is what most people's setups are going to look like. We do that per data center, per team, but why do we do that? So essentially, we kind of committed ourselves to maintaining and managing anywhere from dozens to possibly hundreds of small clusters across our network in order to deploy these applications. And we wanted to retain a physical separation of workloads. Like I said before, we have a lot of teams that have many different requirements. They have many different languages that they're implementing. Business doesn't want application foo with application bar. If application bar crashes, that might potentially cause problems with application foo. So we need to provide some sort of a separation that we didn't feel like that namespaces alone would necessarily provide that. So we're kind of foregoing namespaces and we're using physical Kubernetes clusters as our namespaces. But we found out that it's really not that difficult to manage when we're just managing the deployment against those clusters. So the teams don't have to remember these endpoints. We have a file that essentially says, like a kubeconfig file that says, here's our endpoints, these are the clusters we deploy to on our CICD pipeline. So the developers never have to learn anything new. They just say, I want to deploy to dev, I want to deploy to staging, I want to deploy to prod. And on our CI/CD pipeline, we take care of everything on the back end. We do a lot of resolution. We make sure this team is deploying to their cluster. So we're not doing cross-cluster applications necessarily. We're not doing cross-team applications or something like that. Every team is sort of siloed in a certain way. So they're managing their applications, and they want that segregation. So what does our CI/CD pipeline look like? Again, nothing is too crazy about this. It's all Jenkins driven. The developers pull their code from GitHub. They pull our created approved base image from our image registry, and then they build their application within that container. Nothing incredible there. The next step that they're going to do is they're going to do a security compliance scan and image push. So we maintain a second registry that only has approved images for deployment on our side. So we, again, security scanned it after they put their code into it. So we security scan the base image, they put their code into it, we security scan their application image. And once it meets our requirements, we verify that it comes from one of our base images. We verify that it is secure, it's not vulnerable to any CVEs. We do a promotion step and we essentially push it to our registry that nobody but us has access to. So not even the developers have access to this registry. So we're segregating our images into its own secure registry that nobody else can touch except for the WebOps team. After that, they can simply trigger the deployment to dev, staging, and prod. We're doing a little bit of logic, so we're making sure that in order to deploy your new application image to production, it does a check to make sure that it's already deployed to staging. So we're kind of providing a little bit of an assurance that there was some semblance of testing. They're still in control of their testing mechanisms because we don't know specifically what their application is doing. There's many applications that get deployed in the Bloomberg web world. We don't know all of the testing criteria for them. And for a team our size, it's just, what, 6 of us about. We can't maintain those testing mechanisms in a way that's going to meet everyone's needs. So they're using different languages. They have different types of applications with different frameworks. They have different needs. They have different acceptance criteria. We can't control everything. So they do their testing. We give them a method to deploy to dev. They would trigger their testing externally to our CI/CD pipeline, and then they would deploy to staging. They can test again, and then they deploy to production. So we're giving an assurance that wasn't necessarily there before, except by a manager saying, yes, this was deployed, or this was testing, or this is a good deploy. We're at least forcing them to deploy to staging first, so they know that it was deployed somewhere else, and it didn't break everything when they deployed it to staging. So the flow. The developers control their builds. We created Jenkins jobs essentially and allowed them to access those Jenkins jobs using the remote job API. So they don't necessarily need Jenkins to do something. They can pass a JSON blob to the Jenkins API that we control that just dictates their deployment parameters. So we give them the ability to upload secrets that are going to be loaded as environment variables in their application. We give them the ability to control the scaling if they want to. We give them the ability to take advantage of a lot of the functionality that Kubernetes has underneath if they want to, but we have same defaults also set for all these things. So if they aren't specifying like memory requirements, or if they're not specifying health check URLs, we're also setting standards so they can just comply with those standards and they don't have to worry about any of this. So some of our standards are somewhat optional in a way, but we're making it simple for them to implement them so they want to implement it and they don't have to worry about changing their methods if one of the developers goes to another team. It's a unified deployment methodology, but not necessarily the same exact deployment pipeline. Each team still drives their cadence. So why do we provide the pipeline? Again, we need that control. We don't want the developers to have to learn new tools every time they go to a new team. We don't want them to have to learn old archaic legacy deployment mechanisms. We want to provide them something that's feature-rich, easy for them to use, and overall result in a better developer experience for them. So that's one of the greatest reasons that we worked hand in hand with that proof of concept team. They created that application, and every time they made a code change, we essentially held their hand, and we wanted feedback, and we required feedback from them about how was it, did it go good, did it meet all of your expectations, what else do you need? So every time they did a deployment, they would say, oh, well, maybe I want to also do this, or I want to think about doing this. So with that application team, we also created the standard. So it was a standard that they knew and they liked and they were comfortable with. And the result, in the end, it's all about the technology. Let me bring this up. Right here, Bloomberg technology, Rerelease. This was our proof of concept application. This right here that you're looking at right now is on Kubernetes, it's containers, it's a big deal for us. It was the web world's first application deployed to containers. It was deployed on a new framework, and it was something that the developers loved doing. We loved providing that platform, and this is essentially the future of the web world at Bloomberg. But again, like I said, this is the web world. So there's other teams such as the DTP team, which they're in another ballroom in the next session giving their presentation about what they're doing. But this meets our needs for the foreseeable future, but again, we needed to retain that flexibility. And we're always going to be requiring that feedback loop from the developers. Is this working? Is this ideal? What do we need to change? But again, we retained all the flexibility from Kubernetes. We didn't use any of the very specific providers that's going to lock us to certain mechanisms. And we're not using proprietary technology where we can avoid it because it's harder to replace that instead of using open source technology. Any questions?
I was interested when you mentioned you have one cluster per team, because to me it sounds like you're going to have a harder time bin packing and more overall over-provisioning needed to scale many things than to scale one large pool. And also, for example, you lose out on the benefit of being able to use the same cluster to scale up one service that needed during the day and then use that same overage or overcapacity in the evening to do batch processing. So what were the trade-offs that you went to come to the one cluster for the team as the idea?
Sure. So the question was, what were the trade-offs that we had to make in order to implement one or multiple clusters per team. And, you know, like he mentioned, you do kind of lose a little bit of flexibility and resource utilization compactness with the applications because you do have to manage scaling across multiple infrastructure clusters. You have to manage application scaling at some level between many applications across many clusters. Really, the key to it is creating a mechanism for spinning up these clusters in a unified method. So there's solutions out there like using Ansible. We're also playing with using Salt to get us maybe a little bit more feature-rich orchestration and stuff like that, because we couldn't really implement the open source Kubernetes deployment mechanisms that are available right now because we did end up having very specific needs for our implementation. So we did kind of have to create a little bit of our own infrastructure orchestration. But again, we also benefit from having a platform where we also right now have API access to create compute instances and stuff like that. If you don't have access to those creation APIs and stuff like that, like if you're using VMware and you don't have access to those APIs, it could potentially be an issue and you might lose out on infrastructure scaling itself. So you're going to have to do a bit of capacity planning where you're saying, okay, I'm going to have to pre-provision ahead of time, and you may not get the full benefit of the actual usability of the resources themselves, but you'll still be able to at least fully implement pod auto-scaling if you need to using Heapster or whatever in HPAs. So you can still scale the application and you can put multiple applications on the same set of tool or the same set of infrastructure as long as you know they're not going to necessarily clash with each other. Does that make sense? Okay. Any other questions back there? So actually, our security pipeline, again, it's all Jenkins driven. So it's essentially when the developers upload their image to our public internal registry, it's internal to the company, but everyone has access to it. When they upload it to that registry, they would trigger that promotion job. And what we do is we pull the image from the registry. We use OpenSCAP Docker to stand up that container locally, and it's as simple as docker oscap -image CVE and then the image name. You do a scan, and we collect the output, what CVEs it is vulnerable to, if it's true to any vulnerabilities, and we provide that as an output, essentially as the Jenkins job console output. So we're leveraging a lot of the innate functionality in Jenkins itself as a sort of job pipeline. But we also do an image SHA lookup where we look at the hash value of the image layers themselves, and we have an inventory of our base provided images that we approve. So we kind of bounce those two against each other to make sure that they at least use one of our approved images at some point. They can build more and more layers on top of it. That's fine. They're going to if they manage their own Docker file. But we're also making sure that at some point they're using one of our base images. So it's essentially a simple collection of shell scripts because there's already command line clients that do a lot of that functionality. We just don't want to do it manually every time. So essentially they hit the job API and it's just a pipeline of jobs that do it for them, and they don't even see what it's doing on the back end. It just happens. Any other questions?
How do you maintain all of these clusters in the version?
So the question was, how do we maintain the clusters and keep them updated? So right now we implemented Kubernetes 1.3.5, and that's kind of the sweet spot for us. We don't really necessarily see the need for our use case to implement further versions in the near future yet. we're going in an immutable infrastructure route, so we're kind of building base images with the binaries on them and the logging daemons on them and stuff like that. So when we do deploy the infrastructure, it's all pre-configured. So if we do need to do updates, we would essentially build a new base image and we would slowly roll that out, replacing members within the cluster. But again, that's going to be after we do stability testing, and we need a driving reason for us to do that, because that's a core infrastructure change that could have negative impacts on a lot of people. So if we don't need to update for functionality or for a dire bug fix, we're not going to. So we see it as being something that we do relatively rarely, if that makes sense. But generally, it would be handled at the base image level, where we would delete the virtual machine, deploy a new one. Kubernetes is going to worry about balancing the applications within the cluster itself. We would just kind of have to trigger a delete and then recreate of the infrastructure. Make sense? Okay, cool. Any more questions? Comments, concerns? I'm more than happy to talk. Oh, yes. So right now, we're using Artifactory for a container registry internally. That's just because we have a team that provides that as a service inside the company. Our registry that we use that's segregated is kind of maintained by us, and we don't know really what's the future of that. We might change who the provider is moving forward. We may change the technology. If the problem that we ran into is Artifactory isn't super granular with the permissioning of Docker containers when you deploy to it. So if someone has delete access to a container on that registry, they can delete all containers on the registry. So there's nothing stopping Team A from overwriting Team B's container technically. So that's part of why we do that security scan and that verification. So we can almost take a snapshot of that container, move it out of that registry that it's not insecure, but it's just maybe not quite as stable, and we put it into our registry. So we're also playing with registry services and stuff like that. We may outsource that to someone else. We haven't really decided that yet. But again, that's part of the whole, we have to kind of stay flexible because this is still new technology and we don't want to lock ourselves into one solution too early and it ends up coming back and biting us in the butt. Any more questions? So we're actually not doing permanent or persistent storage for the applications we're deploying to the cluster itself right now. The problem with that is then you have to come up with a storage overlay or a storage provider, which again may not be available to all of the cloud providers across, all of the possible destination infrastructure. We're playing around with ideas like Flocker and stuff like that, but that's something that for the near foreseeable future, we're not supporting that because that kind of goes against that 12-factor methodology. So for the services that we run on the clusters, like let's say monitoring and logging or something like that, we manage storage for that using local storage, but we're not allowing the application teams to utilize that storage at all because that starts running into messiness when the app has to move and stuff like that. So it's something we want to support in the future, but right now, kind of the state of our setup, it just doesn't really allow that. I think I'm pretty much out of time. One more real quick question. So actually, we had very often meetings, just about weekly, with our security folks where we showed them these are the configurations we're using. These are our concerns. So a lot of the people within our team, WebOps team, is very security-minded regardless. So we already knew a lot of the risks, and we kind of jumped at offering a solution to mitigate those risks ahead of time. So we can say, yes, this is a potential risk, but this is how we're going to mitigate it. You have to understand that you're going to have to make compromises for security, and that's okay. You should. Okay, so I'm out of time. If you have any more technical questions or in-depth questions, feel free to ask me aside. All right? Thank you.